So please give a very warm welcome to L35, Tristán and Alejandro.
Thank you. Okay, thank you. Well, thank you, Matthew, and thank you, BIMobject. I guess we are the weird section of all the speakers because we are the architects. We're going to talk about our experience with BIM. Basically, these 3 points. An introduction, a very brief introduction of L35. Our experience with BIM and the application of BIM to a specific project. And of course, we'll be talking about BIMobject as well. Very quickly, our office started practice in 1967. We have offices, well, you can see the countries there. I mean, the cities, Madrid, Barcelona, Paris, Casablanca, Istanbul, and then on the other side of the water, in Miami, Sao Paulo, in Chile, Bogota in Colombia, and Mexico. We also work in some other countries like Italy, Belgium, India, Qatar, Abu Dhabi, and Egypt, and wherever they call us to do a project, we go there. We are a team of composed by 22 partners, 12 junior partners, and 250 people staff. Okay. Most of us architects. There are a couple of engineers and some construction specialists in the office, and of course we have a BIM manager for the staff. We've done a number of. We were very lucky, and we've done a number of large and complex projects in more than 20 countries, and we work in these mainly these 5 areas: offices, residential, mixed use, retail, and other projects, diverse projects like train stations and stadiums, of course. And I'll just go very quickly through some of the retail projects, some residential project in Istanbul, some residential in Madrid, office buildings. So you have an image of the type of projects that we do. And these are mixed-use projects. This is a very curious one because it's a train station for the TGV. The train, the high-speed train, is a shopping center, offices, 2 hotels, and sports facility as well. A mixed-use project with offices, residential, and shopping center as well in India. I think there is somebody from India over there. And of course, we'll be talking about later on the Bernabeu Stadium, which is our star project so far. In Madrid. It's basically maintaining the stadium and covering the stadium with a new skin and a number of uses that go within the building. Okay, applying BIM at L35 it hasn't been easy, actually. We started about 8.5 years ago. And it's like when we went from hand drawing to AutoCAD. It takes an adaptation to the new system, and it takes also the resources, the type of people that you have. They have to be trained differently. In hand drawing, we had draftsmen. The draftsmen disappear, and the architects have to know much more than just drawing. And from AutoCAD to BIM, a similar thing happens. In AutoCAD, the architects need to know a lot about construction, but under BIM, they need to know much more because of all the elements that compose the project and come together. So to understand all the interferences between all the elements in BIM, they really need to know how a building goes together. So they need to know about construction. How did we do this? Well, basically 3 stages. The first one, we started setting up 2 groups, one in Madrid and one in Barcelona, and training the people using the BIM to generate all the BIM standards and the Revit template and all these other things that you all know. On the stage 2, we applied all the knowledge that was acquired by these 2 teams to a specific project. And once we did this specific project, we went back and rethought whatever happened. We did the analysis, and we redid again. We generated again all the BIMobject libraries and the specific BIM manual for the office. And right now, after these 8.5 years, we've been able to do more than 50 projects in BIM from beginning to end. Not all the projects adapt, or not BIM doesn't adapt to all the projects in the same way. It adapts very well to all the residential projects, to the office buildings as well, but not that well to the retail projects. Retail projects change constantly from day one to the very end, and that flexibility still is not in the BIM process, but for sure we'll get there. Just as it happened with AutoCAD, that it changed dramatically from day one to now, BIM for sure will be adapting to all these needs. We have BIM teams in the 3 main offices, Madrid, Barcelona, and Paris, and we do all the collaborative work with all the consultants, all the engineers under BIM. And basically, well, there are many synergies with all the tools that are combined with the BIM system, with Revit, basically. What has been the impact of on L35? Well, it changed the work methodology, how you go about a project from beginning to end. It changes as I mentioned before, the requirements for the staff. And it requires continuous training, because you have BIM itself is changing, is applying new things, so you need to keep up with that. And it requires also, as I said, that the staff learns a lot about all the elements from the industry, BIMobject, and from the engineers and all the other consultants to really understand how the puzzle goes together. Now Alejandro is going to tell you about the application of BIM to this specific project, which is the Bernabeu Stadium. Here you go.
Now, the Bernabeu Stadium is a project that made us change the way that how we do BIM in the office. Now, it's a completely new skin around the old building. It's not only about the skin, it's about the urban development surrounding it. Also, the roof completely conceals the old building. And it's a building that constantly changes surrounding it. It's a parametric design. There's no way we could have designed this without it being parametrics. Now, this was a complicated building to design. We had several teams, one in Germany and another one in Madrid. So we started off, especially in the concept stage, having the 2 separate offices. Each one had their servers, and we just sync once in a while, about once every 2 days or so, to have the information sustainable. But when the team started growing, we found this was not the reasonable thing to do, so we changed, and we will put the model in the cloud, and we used our servers as accelerators because we needed real-time sync between the engineering teams and the architecture teams. In the first phase, when we only had 2 servers, we used, to share the information with engineering teams, we used Trimble Connect, because this is just a document manager. So we had a real feed of what we were giving all these engineers. But as the information keep growing, we had to change this. We used Bing Colab, which is a real-time feed of information between the teams to see all the issues that were arising between engineers and architects. This gives us a horizontal communication, and that we can really see digitally in each monitor. So it really simplifies all all the information between the different teams. Now, we normally have this kind of scheme of team, and all the information is feeded from the top below. This time, it was absolutely a must to do it in a horizontal in between all the different architects and engineers. Now, we also found that we had people that knew very well how to manage BIM. We knew people that really knew the project, but it was difficult to get just one person to be able to have it all. So we had to mix. We put all the tables and we mixed BIM novices and BIM senior operators with BIM specialists and project experts. So we had to shuffle everyone around to be able to manage this. With the BIM color feed, we also had to digitally use Redbooth, which give us a to-do list. And we had meetings every morning to be able to know who was doing what, and if the targets were reached or if the goals were achieved. So the Bernabeu facade is a parametric one. There's no way we can really design this without parametrics. So it's based on some 3D lines that are in space and that give you the perception and change your perception of scale as you get closer to the facade. So you can see the complete volume when you're about 120 meters apart from the building, but as you get closer, these lines change in reference and scale down the building. This is a very important feature of the building, and it changes constantly changes. This we drew this with rhinoceros and grasshopper in a and we had about 2 people that knew this grasshopper. Now we have many more. The main control points are come out of the old concrete piers of the stadium, intersected with these lines. And they give us these control points to be able to change the design. We did many different configurations until we achieved the one we wanted. And the rest of the geometry, the substructure, everything comes out of parametrics. We have 14,000 louvers like this one. Each one is different. Now, to manage the model and to really get a hold of this, of the workflow, we started out getting this model and just pasting it on top of the model. Now, this gave us awful results, especially in graphics, because they were not elements that were not native to BIM. So they were not correctly represented. We had to do a very tedious process, starting from Rhino, cutting it, and pasting it. So, and every time we did a plan, a section, or even elevation, we had to do this. So it was a very tedious process. So we started training ourselves with a more complex way of doing things. And we started with rhinoceros and grasshopper. We exported this to a database, and we imported it with Dynamo. So each louver is defined by 9 points, and we got those data sets, and we created those 14,000 different louvers inside the Revit model. This is more or less the process. These are the points. We exported them through Grasshopper, through a Grasshopper programming. These are the 9 points of each one of the louvers has the set, and we also programmed in Dynamo to be able to have this just one louver. So this was a very important process for us just about getting to manage all this complexity. Of course, when you have this and it's native, then you can do so many more things, like we could group them for sizes, or we did quantities takeouts out of them. We also add plenty of information, and also the graphic output, it's so much better. And it's automatic. Now, this is a huge and complex building. So we have 5 structure models, 6 architecture models, 5 envelope models for the roof, the different parts of it, and we have documents and plans, 11 models. So when you really open this federated model, it's a beast. So we had to really start with model quality, trying to trim down the models, and more or less we arrived to a 200 megabyte size that we could manage, no more than this. We integrated many object use. Of course, if you take them out of the database, it's so much better than drawing each element. So these are just some examples. This is a BIP zone. We just took it out of the database, and it's also linked to the rendering program as well. So this is all done more or less automatic. Now, once we have this, for example, this is a model that we have with the 80,000 seats of the stadium. Now, we know which one has an armrest, which one has a cushion. We know we have the data of which is the vomitory they're coming through, which is the line. So we can do egress strategies, different egress strategies for emergency purposes. And we have all the data of each seat. We're now helping the club to reorganize all their seating process. And we can know which one doesn't have sidelines, or which one has difficulties, because we have a little program with these heads, and we can have the values that they need to be able to know. Of course, we can also do 4D. Now, unfortunately, this is not being provided by the construction company. We have a missing link there. I think architects, after some effort, can manage the BIM. I think the people that are doing maintenance also take a very big effort in BIM, but somehow the construction site is a very difficult place to place BIM. And of course, we do visuals as well, straight from BIM. So, I mean, BIM is a difficult tool, and you really have to embrace the technology to take full account of all the possibilities that it has. It was a great journey for us, and we're still looking at ways to automize all our processes and take better advantage of BIM. Thank you very much.
Thank you.